Hi everyone, we're Team 12 and our project is Amsterdam Airbnb analysis. This is our agenda, and I believe that all of you have heard about Airbnb, and most of you maybe have booked rooms on Airbnb, and even some of you are the host of Airbnb. Actually, Airbnb was launched in 2009. Currently, it has covered about 200 countries worldwide. So, why it grows so rapidly? One of the most important reasons is its low price and great convenience. Some reports shows that travelers prefer to live in Airbnb during their journey because they think they could fully experience the local culture. So we researched the Amsterdam Airbnb because it is one of the most popular tourist destinations in Europe, and also in 2013, Amsterdam passed the world's first Airbnb friendly law. So, in this project, we want to analyze an Amsterdam Airbnb hotel price changing over time so the host can set a suitable price in different seasons. And also, we want to try analyze customer reviews to know the overall satisfaction and which parts the host can be improved.
Then let's talk about the data description. Our raw data set is Amsterdam Airbnb. It was merged from the listing and reviews details file. It had around 400,000 rows and 21 columns. Based on the raw data set, we choose comments, neighborhood, and ID columns to form a new data set to do the text mining analysis. We use date and price columns to build a time series model. Next, in order to better understanding the dataset, we did some visualizations through other software. The map is the most intuitive way to see the information about the hotel. From the Amsterdam neighborhood map, we could see the distribution of the hotel. The darkest area in the picture, the purple area, namely Amsterdam's town center, has the largest number of hotels. Next, as for this map, we could get each hotel detail information, such as ID, name, room type, neighborhood, by click the red points on the map. Next. Next.
Next, we'll move on to talk about the data analysis, in which we break our data into two parts. First one is the textual data, and the second one is the time series data. By looking at the textual data, we wonder what are the structures we could extract from those words, and what are some general concerns about the customers and what we can get from those data. So that's why we're doing this text mining analysis, where our main focus is on the reviews, and also we're grouping those reviews by other text columns such as neighborhood. As for the time series data, we're doing a time series forecasting, and we're focusing on columns such as date and price. Next. Go back. So this is our text mining part. As you can see in the diagram below, we're doing 4 nodes on the text miner and enterprise miner. The first one is that we import our data, and next we do text parsing, and then we do text filter, and finally we get to the text cluster to see our results. So for the first one, the text import, we first reading our merged data, and because we only wanted to focus on the text data and see their features, we added the variables in the SAS table and choose only the neighborhood data column and the comments column that are for our interest. And then for the text parsing and the text filter node, the main goal for us here is to get rid of some unimportant words and switch our focus on the phrase we're interested in. And also we wanted to get rid of some words of high frequency, but may add a little value to our text mining analysis. So that's why we're setting a list of synonyms as well as a list of stop words. Next. So here are some tables of screenshots from SAS that can show what we did in these two nodes. First one is the synonyms. Please note that in this table, we're not only identifying the synonyms of certain words, we're also identifying misspelled words, words of grammar issues, different abbreviations of the words, and also we're even looking at some symbols that are expressing the feelings, such as the smiling face is actually expressing happiness, so we categorize it to its parent term happy. And also, as you can see, one specific point in our data set is that we're having different names of the hosts that are mentioned in our customers' review. So that's why we're identifying some of the host names and categorize them to the parent term host. Other things that such as the apartment, different abbreviations of apartment, misspelling apartment into the room. The place actually means the Airbnb and its experience, such things like that. And then for the stop word list, we use this list of stop words. It's actually with hundreds of rows, but for the sake of presentation, we only show the top 50 of them. And as you can see, the terms such as I, me, my, myself, we, ours, they do have a high frequency of usage as they're popularly identified as commonly used words. But they add a little value to our analysis. As we know, they're not important and not our main focus. So that's why we're getting rid of them. And as for the results, we can show that in the text parsing node, the terms that are showing a high frequency are Amsterdam, Airbnb, have, room, great, host, location, stay, nice, recommend, and clean, comfortable. As the list goes on, you can see we're really getting the sentiments and the feelings of the customers towards towards their experience during the stay. Next. Now let's move on to the final part of our text mining, which is the text cluster and the results. As you can see, in our data set, we can see it's grouped, the clusters are grouped into 16 different clusters. Let's take the first cluster as an example. It has a cumulative frequency of 33,000, around 33,000, and has a percentage of 8% of all the data. And some popular descriptive terms that are like great, location, host, room, stay, Airbnb, recommend, clean, good, helpful, lovely, and highly. Other clusters are showing the similar patterns. And as you can see, these clusters are showing mostly positive feedbacks from the customers. So our focus here is to do a customer preference analysis where we extract what are the customer's preferences, what do they like from their experience, and these are basically the criteria or indicators that we can set up as a matrix for future evaluation, future assessment, and decision making for the business. So the importance of terms that we get that are things such as the host, location, public transportation, room conditions such as how do they feel if it's comfortable to stay, that are important for the customer and as they values the most. Next.
Moving on to time series analysis, it would be very useful for evaluating time, evaluating price outcomes over time. In this project, we attempt to predict the Airbnb rental price for the next 12 months so that the host can set up suitable prices for different seasons in advance. In these slides, you will have an overview about how we're dealing with the time series. First, we use RStudio to pre-process the original dataset to make it more compatible with SARS. And then we use Excel to export our data to SAS for time series modeling. In model development details, we will discuss how we add first differencing and linear trend, how we identify seasonality and trends. Then we wonder figuring out any critical events that happen during this period. More importantly, to obtain our best model, we decided to select our best fit model based on RMSE, AIC, and BIC. Next. In order to predict the price of Amsterdam Airbnb rentals, we utilize the previous price information during the past few years from August 2010 through December 2018. In a SAS time series forecasting system, we set price as the time series variables that we aim to plot and the interval set as a month. As we can see here, there was a downward trend consistently over the time from the middle of the year 2013 to the end of 2018. Visually, we could inspect the fact that the price of rental has been dropped in the winter each year, and the peak season was summer. Next. To start with fitting the models, we tried the first differencing trend model, but we saw a spike on AR1 in both ACF plots and the PACF plots. However, the plots have become insignificant compared to the original series, so our model was getting improved by adding first differencing. To find an optimal situation, we also try to fit a model with linear trend on the right side. Next. We also need to consider adding intervention on our models. The majority of Amsterdam Airbnb hosts are share of their primary residence as of March 2013. Therefore, it was logical to conclude that there was an oversupply of Airbnb in Amsterdam during this period of time. Another interrupted event was Airbnb announcing that it will collect taxes in Amsterdam starting from January 13, 2015. Therefore, we decided to add a stepped intervention with permanent effects on our model to examine the effects on this policy on tax collecting. Next. We added seasonal dummy regressor to our models because we consider that people would prefer traveling in the summer season and they are less likely booking Airbnb in the winter days. Next. Move on to ARMA. As we can see here, rank 1 were insignificant in both ACF and the PACF plots. So we decided to add ARMA1 into the features. After we did that, we found that there were no spikes above the red lines in auto correlation plots, which means we improve our model by adding these features. Next.
Next is our model selection part. We use 3 criterions, which are RMSE, AIC, and BIC. Below is our model comparison table. We marked the best model in each criterion as red and bold. Combining all the 3 criterions, we selected the model in the green background, linear trend, seasonal dummies, or interventions, and ARMA11 model as our best model. Next. Here is general information about our best model. We can see that prediction error of our model is randomly distributed. Next. Next. Our best models ACF and PACF plots are good, and from white noise and stationary test, we can conclude that our model's errors are truly white noise and its time series are stationary. Next. The last one is our prediction for next 12 months from December 2018. From the results, the price will be generally stable, as there will not be accidental events during this period. Next. And here's our conclusions and recommendations part. For conclusions, firstly, generally customers left positive comments due to the attractiveness of Amsterdam. Secondly, host locations and walking distance to the center of the city were considered most by customers, which is in line with our intuition. Finally, both supply and demand relationship and tax policies could have enormous impacts on the price of Airbnb. As for recommendations, first, hosts should greet and treat customers with a nice attitude. Then, those whose hotels that were not in great locations or far away from the city center in a walking distance to lower their Airbnb price. Moreover, rooms should be neat and clean. Last but not least, hosts should keep an eye on information about market and tax price. Next. Finally, we use Python to make a word cloud image for this dataset. Customers left positive comments such as recommend, loved, amazing, and great. Host Daniel is the champion of all the hosts. And we can also know that customers consider host, place, and room most. All the results are consistent with text mining analysis. Next. We all members in Team 12 hope all of you can stay safe at home during this crazy period. Thanks for listening to our presentation. Any questions?